Okay, so today we're going to be looking at rates of change. Now, rates of change basically are the same thing as the gradient. So say we had some function h and it changed with time in this relationship. So if we were to sketch roughly what that looks like, it's going to be t and h. Something like this. This is a parabola. And the rate of change would be how h changes with time. And the value of the rate of change would be given by the derivative. So say we had this function and we want to find the rate of change of h with respect to t when t equals 2. So h equals a fifth t squared, so we need to find the derivative. dh by dt is going to be 2/5 t. So, and then when t equals 2, dh by dt is going to be 2/5 times 2, which is 4/5. Do another wee example. Variables v and t are connected by this equation. V equals 2t squared minus 3t plus 8. Find the rate of change of v with respect to t when t equals 4. So again, we've got our function. And the derivative will be 4t minus 3. And when t equals 4, dv by dt is going to be 4 times 4 minus 3, which will be 13. Now, sometimes we can have two variables, x and y, and they both vary but with a third variable t. We connect the variables using the chain rule. So if we wanted to find how the rate of change of y with respect to t, we would take the rate of change of y with respect to x and multiply it with the rate of change of x with respect to t. We can also use the rule dx by dy is equal to 1 over dy by dx. So we get this from the fact that, so in this one, say we set t to y, and then dy by dy would be dy by dx times dx by dy. Dy by dy is 1 there, and so that's going to be dy by dx equals dx by dy, and that then gives us, rearranging it, this. Let's look at an example of how to use the chain rule, so it makes it a bit more clear, because this can be a bit tricky to understand. So, a point with coordinates x and y move along the curve y equals x plus 2x plus 3 in such a way that the rate of increase of x has a constant value of 0.06 units per second. Find the rate of increase of y at the instant x equals 3. State whether the y coordinate is increasing or decreasing. So let's consider what this means. So we've got this curve, y equals x plus the square root of 2x plus 3. Now the x coordinate is also something that changes with respect to time, and the rate of change of x with respect to time, so dx by dt is 0.06. It's not a function of t, but it's a constant rate of change that x has. Now we know that y is x plus 2x plus 3 to the half. We'll write it in this form. So we can now work out dy by dx. Now for this one, we were talking about the chain rule for the rate of change, but if we were just to look at this function as a function on its own, we would be differentiating this using the chain rule. So we're going to get 1 plus a half 2x plus 3 minus a half, and then we multiply that by 2. And tidying that up, we'll get 1 plus the half and the 2 will cancel, and that's going to be 2x plus 3, and square root that. So we want to find this out when x is 3. When x equals 3, dy by dx is going to be 1 plus 6 plus 3, which so that'll be 9, so that will be 1 over 3, a third, so that'll give us 4 over 3. Now using the chain rule, we know that dy by dt is equal to dy by dx times dx by dt. So dy by dx is 4/3, and dx by dt is 0.06. So that's going to give us 0.08. So the rate of change of y is 0.08 units per second. Now the y coordinate is increasing, since dy by dt is greater than 0. So this is greater than 0, it's positive, so therefore it must be increasing. So I hope that makes sense.